Hello, this is Geology Basics video, mini lecture number 7, Earth Layers 2 Ways.
Here's what you should be able to do after watching this tutorial and having some opportunity for practice. First, describe the characteristics of the layers of Earth based on composition. Second, describe the characteristics of the layers of Earth based on behavior. And compare and contrast the crust and the lithosphere.
This mini lecture highlights the most important features that give us our two types of Earth layers.
You probably already know about the three compositional layers of Earth: the core, the mantle, and the crust. What makes them different? Let's start with the crust, the thin outer layer of Earth where we live. The crust is composed or made up of silica-rich rock. Silica is a molecule made up of the two most common elements in Earth, silicon and oxygen, with one silicon atom and 4 oxygen atoms. Crust rock has about 70 to 50% silica, somewhere in there. The mantle is the next layer down towards the center of the Earth. The mantle makes up most of the Earth's interior and is made up of iron-rich rock up to about 40% silica. The core is the densest and hottest Earth layer in the center of the Earth. The core is made up of not rock, but nearly all metal made of iron. The major point here is that these layers are different because of what makes them up, the elements and their amounts. To review, the crust is rock with the most silica and the least iron. The mantle is rock with more iron and less silica than the crust. And the core is nearly all iron and considered to be metal, not rock. Another way we can describe the Earth's compositional layers, the crust, mantle, and core, is by the type of rock that makes them up. There's actually two varieties of crust, one that makes up the continents and one that makes up the ocean floor. The continents, or continental crust, is made up mostly of the rock granite, and the oceanic crust is mostly the rock basalt. You've probably seen granite in gravestones or countertops or other kinds of monuments. It's often black, white, gray, and pink crystals making it up. Basalt is what you've seen in lava flows, dark brown to black fine-grained rock. The mantle, the middle layer of Earth, has more iron and less silica than either crust and is equivalent to a green rock that's often found at the surface of the Earth from volcanoes called peridotite. The core is not rock but is iron, and there's a picture of a meteorite here to give you an idea of what we think it's like. The Earth can also be divided into layers by behavior. What we mean by this is that the different behavior layers respond differently when exposed to stress or pressure. Let's start from the surface where we live again. The uppermost behavioral layer of Earth is the lithosphere, characterized as solid rock that's brittle when it breaks. Brittle means that the material or substance breaks or snaps when it's exposed to stress. The layer below the lithosphere is the asthenosphere, which is the uppermost layer that's solid rock but is also ductile under stress. Ductile means that the material or substance bends or flows when it's exposed to stress. Ductile sometimes is thought of as mostly a liquid kind of behavior, but a lot of solids under the right conditions actually behave this way, and that's the case with the rock of the asthenosphere. There are behavioral layers below the asthenosphere, including deep mantle, outer core, and inner core. The deep mantle is very similar to the asthenosphere, but it's not clear that the asthenosphere and the deeper mantle move together, so often geologists will separate them. The outer core is the only layer of Earth that's liquid, so it definitely flows, and that's different than the inner core, which is solid. We'll focus on the lithosphere and the asthenosphere because these upper layers are what impacts us at the surface, including what's important for plate tectonics. So remember I said we were mostly concerned with the uppermost layers of Earth. What we mean by this is both the crust and the mantle, and the lithosphere and the asthenosphere. The small black rectangles are there to remind us that this is the very small slice of the outermost Earth that's most relevant to us who live at the surface. So let's review the two main types of layers. The two compositional layers of interest are crust and mantle, and the two behavioral layers are lithosphere and asthenosphere. But Do they line up? Is the crust the same thing as the lithosphere and the asthenosphere the same thing as the mantle? It turns out they're not the same things, as shown in this magnified cross-section diagram of the layers we're talking about. So there's sort of an overlap zone between the lithosphere and the mantle. The lithosphere includes both the crust and the uppermost part of the mantle, and the asthenosphere is the mantle just below the lithosphere, but not the whole rest of the mantle. Keep in mind that what unites the lithosphere is this is all solid rock, regardless of the composition, that all behaves brittly. And what distinguishes the asthenosphere from the rest of any of the layers here is it's solid rock that behaves ductily. This can be somewhat confusing, so here's a food analogy that might help. That's also a great idea for your next birthday cake. The crust is similar to the vanilla cake. It's made of something different than the layers below it. Just like the vanilla cake is different in composition than the chocolate layers below it, the crust is different in composition than the layers below it. The vanilla cake and the chocolate cake have the same kind of behavior. They're both fluffy cake. That's like the crust and the uppermost layer of mantle below it. They're both brittle in their behavior. The two chocolate layers have the same composition but different behaviors. One on top is fluffy cake and the one below it's chewy brownie. Similar to the upper part of the mantle is brittle, but the next layer of mantle down is ductile. Hopefully this is providing food for thought. Sorry, couldn't resist the bad pun. And if you'll learn about me and geologists in general is we really like food analogies, or maybe we just really like food. So the last big question we'll try to answer here is, how do these layers, crust, mantle, lithosphere, and asthenosphere, relate to tectonic plates? Tectonic plates are made of lithosphere, the brittle upper layer of Earth. Tectonic plates move over the ductile layer just below them, the asthenosphere. The lithosphere on top is continental or oceanic crust, which each have a slightly different composition from each other and different thicknesses. The continental crust is thicker and therefore is usually above sea level and ocean water. The oceanic crust is underneath the ocean in most cases and is thinner, but they are both the uppermost part of the lithosphere and the tectonic plate that they belong to.